Today we are focusing on limit review. I would say this is the one you know the best. This limit paper looks kind of funky. I made it that way because I can. The whole goal with making it like this, I call it comic book notes. You got some fun things that you can shade in later. I don't particularly want you to shade during the problems, but you get done and you want to do it, that's fine. The whole idea is later on, it'll make you want to look at this paper again. Okay? When you're sitting at home and you're like, oh, I want to do something. Oh, I could color that as I look at the notes for a second. It's dumb, but it makes me happy. So that's what we did. All right. So we're looking through some problems. We're going to start off with just some practice, evaluating limits with your neighbor. Try to do A, B, C, and D. Hopefully you don't need a lot from me. Remember, what do you do to evaluate a limit? Plug it in. You just plug it in and see what you get. Go. We're plugging in. That's all we're doing to find limits. So on number 1, I plug in 2. Show me the fingers. What'd you get? You get 3, because if you plug in 2 on top, you get 12. You plug in 2 on bottom, you get 4. 12 divided by 4 is 3. Letter B, I plug in 1. What happens when I plug in 1 on top and bottom? I get 0 over 0. What happens if I get a limit problem? I get 0 over 0. What can I do? Factor, cancel, plug back in. That totally works. What else could we do? I would do L'Hopital's rule because it's easier than factoring. Limit as x approaches 1. What's the derivative of x minus 1? 1. What's the derivative of x squared minus 1? 2x. I take 1, I plug it in. My answer is 1/2. You can do it either way. If you want to factor, factor. I don't like factoring. I would rather take the derivative, so I'm going to do that. Yes, sir? I would say mostly that's multiple choice, but yes, I would have done it better than that if this were not a quick, short response. Letter C. Show me with your fingers what you get on C. Yeah, this is a DNE here. Not a 0, but a DNE. Because remember, if I plug in 2 on top, I get 7. 2 on bottom, I get 0. 0 on bottom. That is undefined, DNE. Letter D, I plug negative 3 in. Show me with your fingers what happens when you plug negative 3 in. I get 0 on top and negative 8 on bottom. If I get 0 on top, that is 0. Those are basically all the different types of problems you could get. You could get 0 over 0, do L'Hopital's rule. You could get just regular numbers. You could get DNE if 0's on bottom, or you could get 0 if 0's on top. Those are the main ideas. Okay, let's look at this picture. This is not the greatest graph of all time, but let's look at it anyways. Limit as x approaches negative 3. Here's negative 3. Do I care what happens at negative 3? Nope. What am I approaching? The same thing as I go from the left and the right. Yep, I'm approaching the same thing. I'm approaching 3, so the answer is 3. If I'm not approaching the same thing, like for example, if I asked you, what is the limit as x approaches 1? As I approach 1, what's the limit going to be? That's D and E because I'm not approaching the same thing. Okay, if I'm approaching the same thing, then that's my value. Limit as x approaches 3. Here's 3. I don't care what happens at 3. What number am I getting closer and closer to? That is negative 2. Be careful. There's some weird hash marks going on there, but that is negative 2. Limit as x approaches negative 5 from the right. Show me with your fingers. What is the limit as x approaches negative 5 from the right? Here's negative 5. 1, 2, 3, 4, 5. I'm approaching it from the right. I get 0. Questions there? Cool. Limits at infinity. I do a bad job of spacing out this box, so I wouldn't write super big up here above. Remember, limits at infinity are the same question as where are the horizontal asymptotes? Those two questions are exactly the same. Horizontal asymptotes are just what's happening with your graph as you go left and right. As you go all the way to the left and the right, what number are you approaching? That's a horizontal asymptote. So remember, you did this back in pre-calc. We did it again in calculus. But if it's problems like A, B, and C down below, you're looking at the numerator and the denominator. If the numerator is less than the denominator, so for example, you've got a big number on top, but you got a really big number on bottom. What happens if the number on the bottom of a limit problem, if you're doing limit as you approach infinity, the number on bottom is bigger? What is that going to be? That means you are approaching 0. You're getting closer and closer to 0 as you go. The other thing that could happen is your numerator is equal to your denominator. Okay, so you've got a big number on top. You've got 4 times that big number. You got 2 times that same big number on bottom. What do you do if your numerator and denominator have the same values in them, the biggest numbers? Those cancel, and we would look at leading coefficients. So for this example right here, my answer would be 2, because it's 4 over 2. And then the last thing that could happen is your numerator could be greater than your denominator. So you do a problem, and you get a really big number on top, and just a regular big number on bottom. If it's bigger on top, what is my limit going to be? DNE, because it's going to approach infinity. It's going to keep growing and growing on top, and so my limit is DNE. Try A, B, and C with your neighbors. See if you can remember how that goes. Here we go. Let's do it. Letter A. Again, these are polynomials, so these are the easier version of this. Looking at that first one, Jacob, where is it bigger, on top or bottom? On bottom. It's x squared on top, it's x cubed on bottom. So if it's bigger on bottom, what's your limit going to be? It is 0. It's bigger on bottom, so it's going to get me 0. Letter B, Cannon, what do you think on that one? Where's it bigger? They're equal. They're both x to the 4. So if they're both x to the 4th, then what are you looking at? Yep, looking at, no, you're good. Leading coefficients. So it's 6 over -2. So his limit is going to be -3. And then letter C, if we're dealing with that one here, Isabel, where is it bigger, on top or bottom? It's bigger on the top because it's x squared on top and it's just x on bottom. So if it's bigger on top, what's my limit going to be? It's DNE, because if it's bigger on top, it's going to keep growing and growing and growing and never stop. Limits as x approaches infinity. Questions there? The other big thing about Unit 1 is continuity, okay? Again, these are the units that are on the side of my wall over here. We're looking at Unit 1 there. Again, Khan Academy does a really good job of breaking these up. But continuity, okay? Just in general, if a graph is continuous, what is true about that graph? There's no breaks, okay? If you were to make a continuous graph, you don't pick up your pencil. That's super simple, but it's just trying to understand what's going on. You don't pick up your pencil if you're continuous. Remember, when we talk about continuity, that is something we have to prove on the AP exam. What 3 things have to be true in order for you to be continuous? These are a 3-way definition. Good. The limit as x approach, I'm going to just say 1 for this case. So the limit as x approaches 1, Alana said the limit from the right of that function has to be equal to the limit from the left of that function. And that needs to be equal to what? The value. So the value in this case would be f of 1. Okay? The left, the middle, I'm sorry, the left, I lied. I can't do that. The right, it has to be equal to the left, has to be equal to the middle. It doesn't matter what order they're in, but those 3 things have to be true. That is the limit definition, or that's the limits approaching continuity. I said that all wrong, but continuity. Okay? There's another way we said this. Okay? We could say left, middle, and right. The other way we said this is the limit exists. Okay? The limit exists because the left and the right are equal to each other. Okay? So the limit could exist. The value exists because f of 1 is there. And then the limit is equal to the value. That is the other 3-way definition. Both of them are good. I think it's helpful to know both of them. Questions with the definition of continuity? Look at that 3-part multiple choice and pick out which ones have to be true. Show me with your fingers. Which ones do you think are true? Which ones do you think are true? I'm seeing a lot of 2s. Some other variety from there. Let's do it. If f is defined at A, all that means, if f is defined at A, that means there is a point. So if you had A, there's a point. All right, cool. I've got a point. Does the limit have to equal the value if I've got a point on my graph? No, the graph could do this. We talk about that. That's a limit. Yeah. The point's defined, but the limit is not the same thing as the value. So that one is not a true statement. Number 2 says if you're continuous. So I'm continuous right here. If I'm continuous right there, is the limit going to be equal to the value? Absolutely it is. That's the definition of continuity. The limit is equal to the value, so that one is true. If I'm differentiable, then the limit is going to be equal to the value. Is that true? Absolutely. Again, that's saying the limit is equal to the value. That means continuous. And if you are differentiable, you have to be continuous. If I'm continuous, do I have to be differentiable? No, but the other way is true. If you're differentiable, you got to be continuous. Okay? Limit definition of derivatives. Okay, we did this a little bit. We really picked it up in a later chapter. But remember when I made you do this guy? So the limit definition is this guy. The limit as h approaches 0. The limit as h approaches 0 of f of x plus h minus f of x all over h. Remember how much fun those were? No, they were bad. But you could do them. I don't need you to remember it. I need you to recognize it. Okay? I need you to be able to look at it and be like, oh yeah, that's a limit definition problem. What about that problem stands out that it's a derivative problem? H, the h approaching 0 thing. Oh yeah, it's going to be a derivative. The other one that maybe not as easy to see is this guy. The limit as x approaches some number c. And then it's just slope, where f of x minus f of c over x minus c. Those are our two definitions. We got to be able to use them. So let's remind yourself how to do that problem here. So we've got this guy right here. You look at it. It's a limit problem. But it's not a limit problem. It's really a derivative in disguise. You see that limit as h approaches 0? That's a derivative question. All right, cool. It's a derivative question. So if I'm finding the derivative, I better know what my function is. I better know what the derivative of that function is. And then I better find the derivative at some number. Use your limit definition, look at that thing, and see if you can figure out those three parts. There we go. We're identifying the function. Jesse, what do you think the function is here?
Is it sine of pi over 3?
Yes and no. It is sine. We don't necessarily want to plug the pi over 3 in yet, but it is sine. Okay? I'd rather you say sine of x. And the way we can tell that more than anything else is normally it says x plus h in the parentheses. If it says pi over 3, what is that pi over 3 here? That's my x. So when I take the derivative and I plug in, oh yeah, I'm going to plug in pi over 3. But it's sine of x. What's the derivative of sine of x? Cosine of x. All right, cool. And Jesse said that x value is pi over 3. So I'm really finding the cosine of pi over 3. Unit circle, pi over 6, pi over 4, pi over 3. I'm doing cosine. What's cosine going to be at pi over 3? The answer is 1/2. Try the second one here. Same idea. They already identified the function for you. F of x is that. You're finding f prime of x, and you're finding f prime at whatever your x value is. Go. We got to identify the function. All right, cool. It's natural log x. How do I know that I'm even finding a derivative here? What about this problem? It's not as obvious here. What about this problem is telling you that it's going to be a derivative question? Yeah, f of x minus f of c. I would say the x approaching 3 and then the x minus 3 on bottom. That should tell you it's a derivative question. Okay, so it's natural log of x. What is the derivative of natural log? 1 over x times the derivative of x. So it's 1 over x. I'm finding f prime at what number? What am I trying to find the derivative at? 3. So it's 1 over 3 done. It's 1/3. Let's just show you this the other way. What if I would have done this? So the limit as x approaches 3 of f of x, so that'd be natural log of x, minus f of 3, oh, that's the natural log of 3, all over x minus 3. If I were to just do it that way, I just plugged it in, I would substitute in 3 on top and bottom. What would I get if I substitute 3 in on top and bottom? 0 over 0. What do we do if I get 0 over 0? Take the derivative. right? L'Hopital's rule. What is the derivative of natural log? What is the derivative of natural log of 3? Remember, that's just a number. What's the derivative of a number? This is nothing, because that's just a number. On bottom, the derivative of x is 1. The derivative of negative 3 is nothing. Then all you got to do is take 3, plug it in. It's 1/3. So you could just treat that problem like a L'Hopital problem and do fine on that as well. I know that's kind of strange, but that works as well. All right, last thing. Just a reminder. I don't know if I have to say this, but I'm going to. And so the limit as x approaches infinity. Let's say I gave you this problem right here. Let's go the natural log. Now let's go 2 natural log of x all over 3 plus e to the x. Now let's go 3 to the x. 3 plus 3 to the x. Find that limit real quick. Find that limit. What do we think here? Show me the fingers. What'd you get? Where is this guy bigger, on top or bottom? On bottom, because I've got 3 to the x power natural log x there. It's a limit problem and at infinity. So normally we're thinking exponents. This thing doesn't have any exponents. Okay, so instead I got to figure out which one is bigger. I know that the bottom is bigger because exponentials are bigger functions. So a reminder of this idea: exponential functions. Okay, something like e to the x or 3 to the x. That is going to be bigger than a power. So like 2, no, I lied. X to the 100th power, or like x cubed. Exponentials are bigger than powers, and that would be bigger than logs. Okay, so that would be bigger than natural log of x or log base 2. Like that is a hierarchy that you need to remember as we do this. What if I gave you this problem though? The limit as x approaches negative infinity of e to the x. Let's just do e to the x. What would that be? It's not infinity. It's going to be, it is 0 because it's an exponential function. Remember what exponential functions look like? It's that guy right there. We get really close to, we're going to negative infinity. We get really close to 0, but we're not going to get it. Just something you got to be on the lookout for. Don't make yourself crazy about that. Questions?